All right, everyone, we good to start? Everyone getting settled in with your laptops because we're going to need laptops because it's more of a tutorial, not a lecture. So please don't fall asleep. Try at least. Because I do in my lectures. If there's nothing to do, just listen while the guy keeps talking. So my name is Kamshan, and I am here as a part of the CPT program. This is the Git Workshop. The Linux workshop is going on over there. It's two concurrent. If you wanted to participate in both of them, we're going to have recordings of each one of them, so you can reference one of the other ones later. And then let's just get into it. Like, what is Git? We're just going to start with it's a Git workshop. So let's start with what is Git in general. Does anyone have any idea? Maybe I would like to ask on someone who has a little bit of an idea, but not everything about it. Go ahead.
A way to share files.
Git? No, I wouldn't say that. Share when you can use Git to host it on a platform where you can share files. I wouldn't say Git in itself is a way to share files. Exactly, that's what it is. So it's a version control tool. So meaning like, let's say you have a file that keeps changing over time. Now before, or even where people in a non-technical field, how they track those changes is they'll just like, let's say if it's an Excel file. So let's say they'll just say book one dash and then today's date. And then maybe if it's a Word document, they'll be like dash final. And then next time they'll change it, they'll be like dash final. So, and this is what actually happens, right? So, and they don't have the technical knowledge. So if we do that with code bases, we're doomed because there's just so much duplication of data that's happening, and that's not good. That's not good for the storage space. And storage is cheap nowadays, but it's also not easy to see what you changed from one file to the other file, because it might be the reason why your project is not working. So that's why in order to keep track of those changes is why we use Git, and its version control is what it boils down to. So Git is a version control software. There's also some few other ones out there, but Git is by far the most common. It's also open source. So we're supporting the open source community. And oh, we're on the wrong section here. Let me switch over. Yeah,
I just wanted to double check that the recording is relevant.
It is. I made sure to start it before. So you see that recording to the cloud.
Yeah.
Double check, sure. Yeah. So yeah, Git is a distributed version control system that helps developers track and manage changes in their code over time. So like we just discussed, it helps you track your changes. With Git, every time you commit or save the state of your project, Git basically takes a picture of what all your files look like at that moment and stores a reference to that snapshot. Now, I don't like the word commit in there because we haven't explored what commit is. So commit is like a picture, a snapshot. So like at this moment of time, your file looks like this. So what it does is, let's say if you have a project, and a project essentially means like a folder, which contains every one of your project related files. So it'll take a picture of those files and say on Tuesday, not exactly, it's not by date, but at this point of time, your file look like this. So what it's doing is every time you commit, it's taking a picture, essentially it's taking a picture of those files. And then if those files, let's say if you have 20 files in there, but you only really change 2 of them, there's no point in taking a picture of the other 18 files again, because now we're going into the same thing I was talking about earlier, where it's duplication of data that we don't necessarily need to do. So just to be efficient. So what it does is it'll take those 18 files and it will reference those 18 files from the last commit, because nothing's changed. So for this one, you can just have the 18 last files and 2 more files that were changed. And Git thinks about its data as more like a stream of snapshots. So your project is more of a stream of changes to your files over time, rather than something like, I would say, at one point, there's a lot of files, and I don't know where I'm going with this sentence, but that's what it is. It saves it like your project as a history of changes over time, because that's what you were building it over time. Now, before we go into actually using it, we're going to be using few words repetitively. So I want to make sure you know what those terms are, because we're going to be using them time after time. And it's simple things like repository, what? It's just a folder, but it's just kind of a fancy way of saying it's a folder. So a repository is a directory or storage space where your project lives. Like I said before, like your project is a folder where all your project related files reside. And that folder plus Git's functionality would be a repository. So your folder has its files, and now Git is built on top of those files, kind of, and it's tracking those changes, and it's adding a little bit of more functionality to your files, or it's actually giving you functionality for you to use in order to manage those files. Okay. Yeah. Thank you. Working directory. Working directory is pretty much just the directory that you're currently working on. So let's say your main folder has a bunch of folders in itself, and you're changing a file that's within the folder. So that folder would be your working directory where your files are getting changed. Just next one is commit. Commit, as we talked about up there, is just a snapshot of your files at that point of time. Now, this is a pretty fundamental way to think about Git, is it thinks of its files as if it's in three states. A file can be in three states at one given point of time. One is modified, meaning you are working on the file right now and you have modified it, but you have not committed it to your database yet. Now, a database, as again, that's just Git. Now, don't want to confuse yourself with Git and database. What Git does is actually stores all those snapshots inside a database. So that's when I say database over here. These technical definitions are copied from the official Git documentation, because it's nice to sometimes get into a little bit of technical jargon to, as long as there's someone there to explain it, it helps. At least it helps me. So modified one would be something where you have changed a file, but Git doesn't know yet. I would say it like that. Now, staged means you have marked this modified file. So when you work, you're not working on 5 different files at one time. You're like 1 file, 2 files, 3 files, you're changing it, you're testing it. And then when you're like, okay, I'm done with this file, but I still need to do some other changes in other files. So what you do is you stage them to be ready for your next commit, but you're still, their work needs to be done because you don't want to commit these files now. A commit necessarily will bunch all your files together for one related functionality. At least what ideally you should be, if you want to implement one function on your project, then all of those necessary changes need to be bunched into one commit. So later on, you can reference back and see if something's breaking or how you implemented it. Maybe a year later, you're just curious how it was implemented. You can reference back to it. So that's what that means. So stage would be, it's not ready to be committed yet, but it's almost there, let's say. And committed means you're done. You're done working on those files, and now you have it committed, you have it saved to Git. As long as it's committed once, it's very easy for you to restore back to it instead of it being in the other 2 stages. So this is just a neat diagram where in your working directory, you're working on your files, and from your working directory, you'll stage files to your staging area. Staging area is just a small area where your files will reside before you actually commit them, but they're ready to be committed at this point, I would say. And then from the staging area, when you commit, it goes to the Git directory, meaning Git will save it. And then when you work on these files, you're back to your working directory, like you're ready to make changes again. just a few more before we actually dive into any demos, because I feel like it's important to know these terms before you actually do and you start using these terms repetitively. We got branches. Now, branch is a version of your file. So like, let's say you have your file ready. I wouldn't say a file, but your project is ready at this point, and ready as in there's still functionality that you always keep building onto it. So at this point, it's working as expected. Now, what you want to do is you want to add something to it. But before breaking it, but you also want to add something to it without breaking like your main version. So what, like, for example, if you wanted to do that with a file, what you would do is you would copy it, paste it somewhere, give it a name, like dash copy, for example, and then work on that. So that way your main file is still there, but at the same time, you have this copy to kind of like mess around with. So that's essentially what branches is, where main is called the main or the master branch is where your code is, all your code is, and that's like your working expected code. So this is working as to my expectations. And now when I want to build on top of it, I would create a branch and mess around with that branch. If something goes wrong, all I have to do is just destroy the branch. I still have my main backup ready to go. So that's how branches work, where you can parallel versions of the project to be like technical about it a little bit, and they allow you to work on different features or fixes independently, being the main word here, without affecting the main project. A pull request. A pull request would be, especially when you work in a team setting, is where a pull request will come into play, where you never, on a team, you never work on the main master branch. A main master branch is kind of, they always keep an eye on it because that's what's being shipped to production servers and stuff. Production means what actually users are working on. So you never mess around with that. You make a branch for yourself, and whatever they need you to do on it, you do it. And then when you want to merge your branch back to the main branch, when I say merge, meaning whatever your fixes or whatever your changes are, you actually want to put it in the main version of the project. What you do would be create a request. You want to request the reviewers, however way your organization works, or maybe you just have a project team. So let's say you all sit together and review your code changes, for example. So you want to request your changes to be merged into the main branch. So that's what a pull request is. And it's a way to propose changes from your one branch to another or the main branch. Merging. Merging is just that process of your separate branch being merged into the main branch. There's issues with that we're gonna discuss later. So we kind of went through the yeah.
When I hear the word mobile, I think like there are files on the main cloud or whatever, and I'm pulling them, I'm taking a copy. But is that not what it is? Like pull can mean a bunch of different things.
Yeah, so you're kind of like confused, and I get that because it's the same command. If your files on the cloud and if you want them to your local machine, you kind of write git pull. That's the command. So pull from the cloud server into your local directory. Here, a pull request would mean you have a branch, your main code is here, and you branch off into your separate branch. Now you want to, so this main branch, it will pull code from your branch. So you're requesting to pull code from, not from the main branch, actually. Now you want to merge those changes together. So that's why it's a request to pull code from your branch into the main branch. So just while discussing all this, we already went through these use cases where the main purpose of Git is to track changes over time, then work on different code versions of your code at the same time. So like if you have a main branch Now, I'm going to keep using these words main branch. So I hope it's clear to everyone. Your main branch is your expected code. It's working as expected. Your team knows what's over there. And if you want to mess around with it, you don't mess around with that. You create your own separate branch and you work on it. Because that main branch, depending on organization, it might be tested and tested as in like there's test cases run on that. So it's working as your client wants or as your team wants. So different versions of your code at the same time, meaning would be, let's say there's different developers, or even in a group project kind of setting where you have your main branch, and now maybe you are working on implementing another feature, and then your friend is working on another feature at the same time on two different branches. That's why it's you are able to work on two different versions at the same time. Code collaboration would be just exactly what I said, where you can work, multiple people can work on the same code at the same time. And storing code remotely would be where what you were saying in the beginning of the workshop will come into play, where now that you have Git, now there's all these different hosting platforms that support Git, then you can put your code over there and then share it with either everyone, that would be open source, or share it with only your friends. Maybe you're working on a project, or even if you're part of an organization, then sharing it with everyone inside that organization. So like GitHub, everyone's heard of GitHub. And there's also Bitbucket and GitLab. I believe also supports Git. I'm not too sure about that. But yeah, these are different websites or hosting platforms on the internet where you can store your code, meaning store your files. So we're going to create a GitHub account. I'm going to need you guys to start, open up your laptops. And if you don't have a GitHub account, create one just so we can work on like an actual test project just in like a few minutes here. So does everyone have GitHub accounts by chance? No? Okay, I see a few no's in there, so that's perfectly fine. We can walk you through it. It's pretty easy. You just gotta log on to github.com. For everyone who does have it, I need you to log in, get your password stuff sorted so you're ready to go. It's going to be pretty straightforward, like you're just signing up for an account on any other platform. You just sign up, enter your details, verify your account, and then it's going to send you a verification email. So click on that, choose a plan, select the free plan. Later on, if you're creating an account right now, later on, there's a way to get the free paid plan for free because you're part of an institute. So I can also show you that. All right, looks like we are good to go. Everyone signed in or signed up? Anyone still working on it? I can give you a few more minutes if needed. No, looks like everyone's good. So I'm going to have you create your first or another repository just for you to work on at the moment. And we can always just delete that later. It's no big deal. So if you don't mind, after you're logged in, click on the create a new repository. So there must be a plus icon right here. Let me zoom in here. On the top right column, there's a plus icon. So click on that, new repository, and give it a name. And just give it a simple name like hello-world. And that just means hello world. Don't use spaces in here. Programmers in general do not like spaces. So underscores, dashes, those are your friends. And most of the other stuff is optional. I know it must show you a bunch of configuration stuff. No point in doing that, except for you're going to have to choose a visibility. Public or private is not something, it doesn't matter. for the purposes of this project. So I would just create a private one. And all the other stuff is optional except the create repository button. That's not optional. You got to click on that. All right, is everyone ready to go with the repository? So we can start playing around with it a little bit. Now, this is kind of an important part. A GitHub is an account online, and Git is a tool on your local machine. There's no way that those are connected already. You kind of have to make that connection. So every time you pull from GitHub, or actually even push, as in pull will always mean getting your files from the internet to your computer. And push will mean once you're done, when you work on those files on your computer, now you're pushing back to the internet just so those files are saved online somewhere where you can always access them. So we're gonna set this up with SSH keys. There's a bunch of, not a bunch of different ways, but there's at least 3 different ways you can set up Git on your laptop to connect with GitHub. And we're gonna set up SSH. This is the most, I would say, most long-term solution, which is also not that complicated. It's a little bit complicated because you always run into configuration issues in the first place. But we're gonna set this up now just so you guys are set up for the future as well. So I need you to open up PowerShell on Windows, or if you're on Linux, the other command is right there. It should already, so on Windows, you have to kind of start the service to do the SSH stuff. On Linux, it's already running, but just to make sure and evaluate that it's running. So the commands are both right there. Windows will be this, Linux and Mac will be the same. Just FYI. Most of the Linux and Mac will be the same. So I know some of you guys might be running into an error on Windows, red error, open SSH, does not something something. So I thought I took care of all the errors when I was setting this up, but apparently not. So easy fix. I need you to open PowerShell as an admin. It's gonna ask you, please, yeah, click on yes. When it's open, use this command. Oh. It'll say it's get capital G dash service, capital S, SSH dash agent. So kind of like getting the status of this application and click on enter. Mine says running. Some of yours might say something else other than running.
Yeah, mom says stop.
Stop. Okay, perfect. So we need to actually start it, and it will start. We can start it from PowerShell admin. The next command will be set service. So capital, both as capital, set dash service, SSH dash agent, and dash startup type manual. Let me zoom in if possible somehow. Okay, this second command right here. Is everyone able to see that and make sure there's no capitalization errors in there? And hit enter. It won't say anything. That means that the command executed successfully. If it does say something, then just ask me what we can do. And the next command will be the last one, where start dash service SSH dash agent. Did everyone follow those commands? Okay, perfect. And if you click, so if you click on the up arrow 3 times, 1, 2, 3, you can get the status again of your now should be running process. So if you click on that, now it should say running. Does everyone say running? Okay, perfect. Now we can start SSH. It already started, I will. And then now proceed with the commands. So use this command right here, ssh-keygen-t ed25519. So SSH is kind of like an algorithm that generates keys. And when you generate a key with that command right there, it'll create 2 keys. One is public, one is private. And then using a combination of those keys is how you actually authenticate with GitHub, like anything online with your personal computer. And again, I don't think that should say, oh, no, it'll actually say some stuff like key was generated. Not be configured to define. So you need to try this in SSH. Sorry, PowerShell admin. This is ISC. This is different, something different. So can you click on Windows? Yeah, click on PowerShell. So, oh, it's not the regular.
CSU, the computer.
Oh, the CSU computer?
Yeah.
Does it let you run as admin?
Oh,
You able to do that? Username would be your CSU ID, password will be your password, CSU password. It won't let you. It won't let you. Yeah, I'm sorry. So you can follow. So this is for connecting with online GitHub. You can follow these same commands when I'll tell you so that you can follow these same commands on your local machine as well. Okay, but it won't let you because this is like admin privileges, so you can't make changes to CSU owned laptop. It's kind of like that. That's the problem. Okay. All right.
For a place to save. Okay.
Oh, I'm sorry. So I forgot to say this. It's going to ask you for a place to save your key. Hit enter. Don't enter anything. And again, when it asks you for a password, now this password, either you can enter it. I don't recommend, I mean, I shouldn't say this. I should say, unless you're going to remember that password for the whole lifetime, I would not enter a password. On mine, I also don't have a password. So just hit enter again. So that means no password. It's going to ask you to confirm your password. Also hit enter again. And then it should say something like your identification. So your identification has been saved in some directory. Your public key has been saved in some directory. And the key fingerprint, random artemis, a bunch of like symbols going on around. So when you see that, that means that's good. Your key was generated, then we'll use those keys to actually set it up. So was everyone able to do that? Be able to do it?
Yeah, I got it.
Okay.
Looks like.
Yeah, that's what I'm looking for. So that's good. Oh, I do say it over here. Password is not required, or so keep hitting enter until a key is generated. Okay, so let's move on to the next part. Now what we just did was create a pair of keys. So 2 keys, one is private and one is public. The private one, you're not supposed to share it with anyone. And the public one, but a combination of those keys is used in order to actually authenticate yourself, saying like, hey, that's me to GitHub when you push and pull code from online. So that's how that works. I didn't understand this until much recently. Okay, it was set up, I didn't touch it, and I'm like, it works, it works. I don't want to touch it. That's gonna be your motto soon too. If it's not broken, don't fix it. So what we're gonna do is we're gonna take the private key and add it to our machine's SSH agent. Private key goes into our own machine. So that's the command right here, SSH-add. So now I need you to switch from PowerShell to your local terminal. So close PowerShell and Windows and write terminal or CMD. So just leave. So just we're good until now. So was everyone able to get that copy the public SSH key? It looks like everyone's good. So let's move on. So this public key is what goes into your GitHub account. So this public key, you will have to go into your GitHub account settings and click on SSH and GPG keys and add SSH key and just paste it. So the instructions are right there, and it's just going to, oh, where's my mouse? It's not working. Okay. So just go to your GitHub. Top right corner that represents you and click on settings. Inside settings, it's here, SSH and GPG keys. I don't want to click on it because is the GP, you know, there's a small fingerprint on there. Is that like,
It's your public key, it won't matter.
it's okay. All right. That's what I was, that's true.
That's true.
So, and then click
That's why
on,
you put your public key here. Your
Right.
Private key stays home.
uh,
And the fingerprint is just a way to shortcut and look at what is the contents of the. So that's just
Okay,
a quick
it's
way
not
to-
even the whole key.
That's not even. the whole-
okay, perfect. And click on new SSH key, give it a name. The name doesn't matter. It's just for you to use later. I mean, just for you to reference later. And then maybe like the name of your laptop would be a good title. And then give it a title and just paste the entire key in here. And so don't switch this, leave that on authentication key and click on add SSH key. Just gonna give you a second to get that done.
Authentication, right?
Yep.
Yes.
Maybe in about, as far as you can, 2 minutes. And then we'll air into this thing. If people want to stay late, they can. His thing is 50 minutes.
Okay,
So at 4:45, we'll switch and then we'll switch back.
Right, it's, oh yeah, it's 3:85, it's not 45:30.
Mhm.
Right, so we have from here. All right, just got told we need to kind of hurry up because we only have limited time. We're more than welcome to stay over, but everyone might not be able to. So as long as you are able to add it successfully, when you execute this command right here, SSH-T git at github.com, that should say that IAO and then your username you have successfully authenticated. So can you retry that real quick? It's good? Okay, perfect. Yeah, so first time when you SSH to this, it's gonna ask like, do you want to connect to this? Like with SSH, you have to tell it like, yeah, I know what I'm connecting to. So just connect it. So just click on Y and enter Y. Well, you have to write YES, yes, and enter. You see? Hi, your username successfully authenticated. Okay. Was that good?
So,
Oh,
is that okay?
yeah. Hi, your username successfully authenticated. And same thing here. Hi, and then your username. Okay, perfect. Yeah, that's fine. So permission denied public key. So that could be, check if it's added correctly. SSH dash agent. So, and believe it's space dash list. Um, then look up what's the command to see SSH agent list keys dash L. Is this SSH? No, but it's SSH dash add dash L. So it's here. Okay. And you also added this specific thing.
Wait, is it that? This isn't github.com. Should I?
No, that's good.
Okay.
This is good.
And is it my username or is it Git?
No, git at github.com. PTY dash capital T. Maybe that could be an issue. I don't know.
Oh,
Hopefully it works. Oh
my
yeah.
bad. Okay,
Okay.
thank you.
Then you're good. All right. Is everyone able to connect to that address over there? It says what we needed to say. Okay, perfect. Now, what we can do is we just created a project, a repository online. And now we want to create, we want to take that online repository to our computer. So let's go to the repository that we just created. Let me show you how. Just in your GitHub, maybe just go to home, and somewhere on the right it should say your username slash hello dash world. So we want to click on that, and it should pop up something like this. There will be no files, but that's fine. But we want to go to this page, and that's important. We want to click on code and make sure it's on SSH column, not on this HTTPS column. Just move over to SSH and copy it. And just open up terminal. And write, as long as you want this folder to be in your users, like your home directory, just write git clone and paste. Or you could switch over to like downloads or documents or something, CD, document, CD download, something like that. So just git clone and paste. What do we? Okay, yeah, just copy that SSH thing. Yeah, perfect. And then yeah, git clone, paste, enter. Oh, term git. So did you download git before this? Before this? Yeah, or no? But did you download it or not? Did you?
I signed in from here. You can
Okay.
like download
There you
it,
go.
Like,
an application.
yeah,
It's all from-
yeah, did you, or do you remember doing that or no? Okay, okay, all right. So let's do this. Git.
Something in there, yes.
Yeah, it's okay. It's not too big. Okay, it's not perfect. Go to this, write git download, just Google
Yeah,
git
so it looks
download.
a little different than. But it's the same. With SSH. Then that is the way to find it.
It's also kind of my mistake where I had you do all this, but I never told you we have to download git. We just leave, honestly, all of this, SH, okay, yeah. Yeah, thanks. Too much, asking for too much. Okay, there we go. As long as this. Okay, looks like you have it. So are you able to run that git clone thing? Huh? Yeah. You appear to have cloned an empty repository. That's fine. It's just a warning. Yeah, because it's empty. There's nothing in there.
Yeah.
Right?
So.
So yeah, it should have. Let's see. The hello dashboard. Let's hear. Yeah. Okay. Yeah. Or yeah. Or but it doesn't matter. You could just finish. And then that command should execute. Can you close this and open it again? Yep, that's good. Okay, see? Perfect. All right.
I couldn't see that.
Yeah, git clone. Yeah. Oh, you couldn't see my bad. Yeah, it is. So it's hello dot git. Okay. It is. Git clone. Oh, Git is not downloaded. Okay. Hold on, give me just a second.
Yeah, I'll show you what else was.
Yeah. We skipped over the part where we download.
Well,
Improvise, I guess.
yeah, just
Provide-
download it.
Okay, all right. So it looks like some of you might not have Git already, either just prepackaged or before this class. So did someone see Git not recognized as an external command, something like that? Someone see it? Because we were able to fix it for 2, but anyone else? So did the clone work then? Okay, looks like I'm seeing a lot of yeses. Could you help her download Git on the CSU laptop? Did you get that?
Downloading
Okay,
Git.
okay. So don't have to change anything. Next. It's a bunch of configuration that we don't even know. And as long as when this is completed, close the terminal, start it again.
All right.
And then that command should work.
On that. Yes. Not the right version. You want 2.4.5. Or you won't be able to do SSH.
And also does everyone have VS Code on your laptop or some kind of text editor? Okay, VS Code, pretty popular, so I feel like everyone has it. Okay, so now what we need to do is we want to open this project up with VS Code. So the command for that would be if your project was named hello-world and if you didn't go into that folder, it would just be code hello-world and hit enter. So that'll open up your folder in VS Code. So did that work for everyone? Here, I can try it. So, and it's going to ask you on a trust. Yeah, just click open and then it should be right there. Was everyone able to open that in VS Code? No? Yeah, so VS Code, or do you have anything else like IntelliJ? Okay,
Yeah.
but that's IDEA though, right? IDEA kind of only works with Java. I feel like, no, definitely not. Um, Probably, but it's gonna take a bit is what I think, and we have time, but technically like 3:30 to 5. So we can definitely stay for longer than that. Also supposed to finish at the same time. So let's see.
And then
It's
where
not
is your-
actually installer.
The SSH address thing.
It's big, right?
Out of storage.
No way. Okay, it's not bad.
Okay.
Right? What about you? Seriously, there's no space?
For real.
The 0 bytes free. Yeah, that is something I can't help with. Unless you want me to just delete all your stuff.
No, I was
So,
I just read that.
all right, so did we open that up in VS Code? Okay, perfect. So after that, click on this green, no, not green, just new file icon. And so this is now just you initialized your project. It's connected with Git. Git is tracking it, everything. Now you actually, let's say you're starting to work on it. So you would create a file and it would be any file, especially be a code file. But for now, we could just write hello.txt and click enter. And in hello.txt, just write something like, let's say my name is Darshan, and click on save. When you save that, you'll start seeing stuff like mine is blue, your might say you with green like text and say you untracked. Here, I can do something like this. Hello. Oh. Word.txt. So it'll be something like this. It'll be green and untracked. So this, you just added a new file that Git does not know about. So it's saying that this file, I'm not tracking it. So what you have to do is maybe let's just give it some content. So like just write your name on it or whatever. And let me just zoom in a little bit. Can't zoom in here. Okay. So, and then now this is where those three states come into play for Git, where a file is either part of the database and then you start working on it. So first you tell Git that you want to, and you already, this file is already modified. So we want to state this file so that it can go in the next commit. So it will be, the command for that is git add hello. I'm writing hello1, but for you it's hello.txt because that's the name of your file. Make sure you save your file as well. And then it should just be hit on enter. not gonna say anything, but you're gonna see that U changed to an A, where it's index added. So kind of like staged, your file is staged. Was everyone able to do that? How do you make it turn green, you say? So did you create a new file called hello.txt? Did you put something in it and did you save it? Huh? Yeah, just put some text in it, like open it up and just put some text in it and save it. Simon, could you see? So on your U means untracked. And untracked means for the first time when you create a file, Git is saying that this file is not tracked. This is not a file that I know about, and I'm not tracking that file. So for the first time, it will say untracked and then you can add it. Once you add it once and then commit it, then it will be, for the next time, it will be modified. So I know about this file, but now it's modified. But for the first time, when you create a file, it will be untracked U. After that, when you add it, it will say index added. And after that, you can commit this file, as in save the state of this file. So like right now, my file will say this. And then in just give up. Internet issue. Okay, but we're back up. And git commit -m. I'm sorry?
You lost your sharing.
Uh-oh, okay. Let's see. All right, thanks for that. And then git commit -m, and within apostrophes, give that commit a name. Now there's conventions on what to name commits, but for now we can just write add hello.txt file, or just anything. What you write in here doesn't matter, but that's the name of your commit. It's something that other developers or you are going to reference later in the future and see what you did. And hit enter. Now you modified this file on your local laptop. You also saved this file on your local laptop. And when I say, I mean saved in the context of Git, not just saving the file. So Git stored it. So if there's some issues, Git is able to retrieve it back. But if you go over to your GitHub, it's still not going to say anything. My hello one is not here. Yours doesn't have any files at all. So there's something with that, right? You did something on your local, but GitHub doesn't know that. You have to actually push that change, those changes, or your commit online. For that, the command is git push. For the first time, that's not going to run, right? It should say something. Mine is going to run, but yours is, you're doing it for the first time. It's not going to run. Right? Can anyone tell me what the error is? Someone try that? Is that, huh? It's running, okay. Yeah, so upstream, it's kind of running into an error because you're telling it git push to git push is pretty much push it somewhere else, but it doesn't know where exactly to push it. So the command for that is, for the first time, you have to say, I believe it's within git push or set upstream. But do you remember, like git something and dash
You're a
dash?
gangster at the command prompt, so I would use the interface on the left, but I think you do git push origin /main, tell it the branch and location to go.
Okay, yeah, or yeah, we don't have to set the upstream.
Right,
I mean,
because it's already in the git tracking that's happening.
right. So I would try this, git push.
Okay.
No, this will work. I just wanted to set it like set upstream always, so we don't have to write that every time.
Darshan, it's the double dash, set dash,
Yeah.
upstream. That
Yeah, but is that an option in Git push itself, or is that okay? All right. So for the first time, we can do this: Git push dash dash set upstream 2 equals to origin slash main, I believe. And hit enter. Okay.
Upstream's one word. Push arrow up and then get rid of the extra dash you have.
Oh, yeah, you're right.
I don't think you need the dash.
Yeah, you're right.
It's just set upstream.
Okay. I feel like I literally,
space origin.
Yeah.
oh, no equals, okay.
I think for this is push origin.
Origin.
Oh,
Yeah.
I have a map, yeah.
Might even be master. It is main.
Yeah, they switched that once.
Okay. Okay, so that should work. So this is the command right here, the one that I highlighted. I can't seem to zoom in. So that's gonna have to, okay. That's the command right here. Git push and dash dash set dash upstream origin. Did that work? Yeah. I'm sorry? Yeah, you need to add commit because that's the commit is what you're pushing online. So you need to commit it first and then push it online. Commit is, yeah, okay. Or I can show this. If this is done, there's also now VS Code, as nice as it is, gives you a way to use Git as a bunch of buttons instead of all these boring commands I just showed you. So Git add would be here. Let's say your file, now change your file. Just change your file to something else. Make any changes, add a line, delete something, doesn't matter. And then it should say modified. Is everyone ready? Okay. Now, when you go over to this source control, that's the third tab on the left. It's going to say changes 1, and it's going to say your hello.txt is modified. So when we wrote git add to add it to the staging area, here there's a nice little plus button to click, stage changes. So it's going to go from changes to staged changes right here in VS Code. Were we able to do that? And then there's a comment right here. If you want to try it, give it a message and click on that tick. Comment changes on main. Not do it. Oh, so you need to, okay, so close this, right? And then I said, change this file. Probably like maybe add a line something, right. Save. And when you go here, that is weird because let's see. It is not staged because it's already staged. Maybe. It is not staged for commit. Not. Your VS Code is behaving weird. It's not able to track even though you are changing stuff, which is weird. I've never kind of seen this, so I don't know. I'm sorry. You can, but here's those commands I showed you are still working. Git add, git commit, git push. Were you able to push it?
Yes, I was able
The
to.
upstream, and then did you see it in GitHub?
Sure.
Yeah. Okay. See, that's good. What's up?
This is fine.
Oh, it's good. Okay. All right. So were we able to do that? To use like the fancy buttons? We kind of, so the reason I showed you the commands is you kind of need to know how the commands work before we start using this. Because once you start using this, you're never going to want to even learn the commands and how they work. And 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 using the buttons is fine, but you know in the back of your head that when I'm clicking these fancy buttons, it's what this is what it's actually doing. It's not like, oh my God, it's doing so. It's just executing those commands for you. It's not. It's pretty trivial. So like you could build something like that in the future, right? And then now when you actually go over, as long as you were able to push correctly, when you go over and you refresh your GitHub page, it should say, it should show you your file, hello.txt, along with the commit message, your latest commit message. So that's kind of how Git works. And before I pass it along to Aaron here, so this is what we kind of, so we also have like this notebook that should have been shared with you. And we kind of went over most of these things here where it's making you echo hello world to txt is pretty much make a new file, hello.txt, and put hello world in it. And then when you go and you can inside VS Code, add the file or use the VS Code integration and make your first commit. And this is what we went through here is you have your Git repo and well, we haven't gone into branches yet, but this is what branches. Now this, let's say, for example, this is your file right now, right? Your project, this is how it looks right now. Let me just comment that real quick. So I can get, well, actually, I could on stage and discard. Okay, perfect. So this is what your file would look like right now. Now, let's say, for example, this is how your project is supposed to look like at the moment. And now there's multiple people, or you want to work off of this state. For example, like now you want to make changes to this, but you also want to be able to go back to this at any point of time. So this is how you would create a new Git branch. The command for that is git branch -b and give it a name. Like, let's say your branch is called test. So let's try that. Git branch -b test within apostrophes. Might work without the apostrophes if it's just one word, huh?
It needs, yeah, it has to be a contiguous word. It can't have spaces. So.
Okay, but it will work even if it just is. Okay. Git branch -b and give it a name. A test is not a command, test is just the name of your branch. Could be anything. Hyphen what? Oh, that's what git checkout -b. So that's what, okay, I see. That's my bad. Well, git branch test. Okay. So no -b. I kind of have the essence of all this, but I'm kind of figuring it out with you guys at the same time. So this will create a test branch. And this test branch, because we were on main, we were on the main branch and that was our only branch, but we were on main branch while we executed this command. So this branch was branched off of main. And like at this exact, so like how your main looked like 2 seconds ago is what it branched off of. And your test branch will now be branched off of, like it'll be connected with that commit. Now you can start working with this branch here. You can say this change is on the test branch, right? And it will modify that file. Let's use the buttons again and click on the plus button to stage it. And once it's staged, give it a name like first commit on branch test. And click on commit. Push would be when you send this change online. If you want to, you could do that. But for now, we just want to see how branches work locally, because there's no essential difference between branches locally or branches on the cloud. On the cloud is like now there's always a copy of your code online on the cloud, but branches is more of it's also there online. It's also there on your laptop. But we're just checking to see how branches work in general, regardless of they're on the cloud or on your local machine.
Will the main one is do?
No, that's the essential point of it, where on your main, you know your code is working correctly up until this point. Now, if you want to make any changes and just test it out, you make a new branch and you work on it. And at any second, you can switch over to your main branch and it will be the same code you had before you made those changes. So this is kind of how, let me switch back in real quick. So let's see, you had code up until here. And up until here, everything worked correctly. Now you want to change your code to add something, add like a feature or something that might potentially break meaning your project stops functioning as expected. So that's why you added this line, right? And now after you add this line, you test your code. So like there's test cases and stuff that will check if your code is still behaving exactly like how it's supposed to be. But this is on a branch. So at any second, if you click on Git checkout main, your IDE should go away in a second. Oh,
It's okay, you made a small mistake, you made a new branch, you didn't
check out to it. Oh,
So you
okay.
actually committed to main.
Right.
It's okay,
Okay. So
check out the branch.
check out the branch first. Okay, so we made this
VS
change.
Code in the very bottom left in VS Code, you have on that, very bottom left, click that, and you can change to the branch.
Ah, okay. So do you want to come over, show like some of this weird
I'm happy
code?
to let you talk or talk as much as you allow me.
Because some of the like this stuff, I can understand some of this stuff, but
I'm
like,
happy to talk through any of that.
yeah, sure. Like show them some merge conflict stuff even, and then the
All
remote.
the things.
Okay, perfect. You want to come over?
Sure.
And then I'm gonna let Aaron here take over for a bit at least and show you how instead of my commands, do it his fancier way.
No, they're not fancy, not fancy.
Um,
Very good job, Sean. So it's just share on the screen share?
you could.
Okay.
Wait, no. Do
No.
you need that? No, you don't need that.
We're on meeting,
Yeah,
right?
So
Okay.
just share, because that meeting's right over here. So as long as I stop sharing. Oh, and you're already.
Yeah, so you just
Right, yeah.
stop and then I'll join.
Perfect. Should probably use this.
Okay. Go to full mode on this. Yeah. Okay. Dr. Barbari always did that. Everyone remembers Dr. Barbari's class? Yeah. All right, let's figure out if this works. Okay. All right, my name is Aaron Roberts. I work with that young man right there, very talented engineer named Joe Rachopi. We work for IS&T. That is a department here at Cleveland State University. Don't screw up and say Ohio State. I used to work at Ohio State. So we provide central IT services for campus. I'm also an undergrad. That's perplexing and might cause paradox in your mind. Talk to me afterward. I'm returning to school to be a master's student in AI and big data and applying analytics and large language model solution for business intelligence, okay? There were classes I didn't take when I was an undergrad. I'm now taking those classes. We work under the president, under the CIO. And so this is kind of an org chart that didn't exist. So I went to Outlook. There are people on here that don't work with us, but we work with all these people, okay? Our role is enterprise application management, okay? So we deal with all of these tools every single day as part of our job, okay? And part of that is managing data services for HR, for the student systems, all the integrations around those systems, pulling and pushing data into these things and making your student experience wonderful. That's our goal, okay? We've got multiple departments in our team. So we have infrastructure, security, and ops, networking, messaging, all the things that you would think of that make up what are an enterprise team for IT. So most of the things we center our work around is pulling that ERP data in and out. So who are you? How do you authenticate? How do you get licensed? How do you get mail? How do you get locked out of your CSU PC without a lapsed local administrative password? All those things, that's what we do, okay? Let me go to the next slide. So Darshan mentioned, we opened with what is Git, okay? And we had some interesting answers to that. I have a different opinion about what Git is as a responsible state agent. Git to me is managing risk in the organization, okay? Because I have to view everything as not my project, but this is something delivering service, right? Like this is a program that delivers service to provide value to the university and to the state and to you guys as students, okay? So the reason we use Git and source control and change management is to mitigate that Wild West that Darshan described, right? Like, and Joe will start laughing as I describe that, but imagine a place where we just make copies of files and programs and put dates and times and stamps. So that's definitely not something going on here. We apply solutions to fix that by using tools like this, okay? So very much a large part of why an organization adopts tooling like this is to mitigate that risk and help us as an organization manage change, all right? So this is a marketable skill for you as young engineers, and that's important to remember. And again, our role is service delivery. So if I allow version 2025 Monday-1 test, I don't know if this is real.txt to run, right? Am I disrupting service by doing that? So a lot of this is centered around, mitigating that impact of services, okay? The second part that allows us to do is kind of roll these things back when there is a problem, because through good management, as Darshan and Simon kind of explained, one of the things we're doing is tracking that version, right? So we can actually go back to the version before the second line of code broke our program, right? And that's a very important part of IT service delivery. So being able to mitigate risk, roll back changes that impact service disruption. This sounds like a commercial, but it's part of the enterprise job of doing real IT work, okay? Now, you might try to ask, well, why is that such a big problem? And what I would share with you is the picture down here is not all of CSU, but it's a large part of CSU. So you have a little program, my happy program, and it actually runs way down here on a server, one of these boxes, that also has to run a whole lot of other things and also has things that might interfere with that. And so a large part of this game is controlling that change and managing how it gets somewhere, okay? So Git to me is way more than change tracking, right? It's risk mitigation. It's moving things into my environment. It's providing solutions. It's helping a developer. It's splitting up a program so all of us can work on it, actually, right? If you think about a really complicated program, Visual Studio Code, we can't all be working on the same things, right? So, and as we solution towards that, these tools have come out, and it's important that we understand how to use them. you spoke about another model of source control, and that's a non-distributed model. So Git is a distributed source control model, meaning there's a central server. You can commit and do things local, be on a boat down in Fiji. Great, check in when you want. There's another model called Visual Source Save that's like the library model, right? Like I'm going to take out code so you can't work on it. And then when I check it in, Spencer can work on it. So that's a different way of doing this, but it also has challenges, right? Because if I have a dependent component and I have to now work on that and someone else might need it, they can't check things out. So Git actually came out of the need to do this. And it's not surprising that it's open source because this is the backbone to Linux and Unix. So this was baked in at the very beginning because they needed to be able to do distributed programming on a giant open source platform, okay? So that's some of those pieces. And like, again, I want to stress that it's a little bit of a different model than just changing code. And I think you had a really good question, young man, about the pull, okay? So from an IT administrator's perspective, our job is to protect that program that's providing service, right? So when we think about why is it called a pull request, it's because I am on the main branch, always. That's where the organization lives, right? The organization runs and provides services for main branch. So it is a pull request into main, okay? And that's a really, if you start thinking your mind, like changing what you're thinking about there, that'll help you understand that process. So if you go to the open source space, it might be create a pull request. You're suggesting an offering to something, right? Because that project belongs to Darshan, not you. You're going to add a feature, so you submit a pull request to Darshan. It's up to him to take it, right? It's up to him to decide whether he wants to have that. So that might help you with the terminology, right? Because the most important thing is that main program line, and we want to protect that. So Git provides capabilities all across the environment, okay? And it's not just what you're doing as a developer, right? You have activities that you do as a developer, check in code, check out code, space out, do your things. But the environment also uses all of this, right? The whole environment is actually code now. So we have parts of our system that are using build definitions. That's code managed through GitLab. We also have stages of the pipeline that do things like test automation or publish or package or deploy. Every single piece of this is part of the environment managed through a repository and kind of orchestrated and controlled through Git, okay? So the pipeline is taking your code and moving it through the environment to get it somewhere, okay? Because again, our role is to provide solutions and service delivery, right? We don't just write programs for class, we're doing things that are real. So that pipeline's job is to mitigate the risk of moving that piece of code into the environment, okay? So again, that pipeline is managed as a code artifact, and we work on those pieces and mature them, and we change the definitions of them, and all of this has to be done with the mindfulness of everything being dependent on each other, okay? We actually centrally store our build definitions. So, as you can imagine, we write lots of programs. I think my inventory is about 150 right now. And there's a myriad of languages that are involved in that. And so when we have something that's in language Java, I don't want 45 definitions of the Java build, right? I want one. So actually what we've done is we're pointing all these things to kind of pull and bring them in and reference them in a central location. Again, all managed through Git. So it's this very important tool that we use throughout the whole life cycle of building software, and the whole environment uses this, okay? One of the interesting things that happens within the build stage here is through automation, that will actually go and check out your code and pull it down into the container. The container will then run its series of steps to compile and then move through that process. So the Git actions that we just ran at the command prompt are also used inside the pipelines and inside the container orchestration environment, okay? And we're gonna get to what that is here in a minute. So the whole environment really leverages this idea, okay? Now, I think Darshan did a really wonderful job walking you through command prompt life as a developer without a GUI, which was like the 60s. Now we have interfaces that do a lot of these things. So tools, most of them have some kind of way to deal with this challenge, okay? A couple really popular ones are SourceTree, VS Code, Eclipse. These are all large programs, IdeaJ, that'll have native source control plugin pieces. And so these activities that you're doing are pretty typical, right? So if we're gonna start a new project, we're gonna clone that repo and it's empty. Well, I don't wanna start from scratch, so we actually have stock template like repositories that have a whole program ready to go. So if Joe needs to work on something, he's not going to start with an empty repository folder. He's going to get a running program configured with build and all these things with that backbone of Git in place, okay? So we kind of leverage these things at scale. And again, the branch, I would agree with your assertion there. We branch by feature, okay? There are other patterns I can show you that we do, but primarily we branch by feature. So a typical use case, Bikes Connect isn't working, okay? That I get a call. And so I have to fix something. I'm gonna immediately get a hold of Joe, he'll branch, start working on that branch, figure out what's going on, and then we'll merge that branch back in and move about our day. Now, a couple comments on commits and some push, okay? You wanna commit often. There's an old commercial by Wilford Brimley that tells you to check your blood, check it often. You wanna commit your code often. This is an opportunity to allow you to roll back. If you go all day, you go to lunch, you go home, come back on the weekend, come back to work, and you haven't committed, you can't roll back to before you went to the weekend, okay? So my advice is commit pretty often. And again, you're doing all of that local. You're not gonna push this to the server. So, you know, as you work through solving a problem or building pieces that make up something worth others having, those are commits, okay? A feature that you want to then kind of push is something that another person could use, right? I'm going to add a menu item, or I'm going to build a menu. Well, work on the menu. When you have that working that others can then use, even if that's version 1, right? Just it renders and has one item. Great, push it. Now Joe has the menu, right? So you can think of the push as the logical grouping of commits that make up a feature worth others using, okay? And that's a good way to think about that. Team projects, there are multiple philosophies about this when we look at source control solutions. There is the Google model. There's one repository, and that's the truth. You get hired at Google, you're gonna go get access to the whole source tree, and that's overwhelming. And that's Google Search, Mail, Android, the whole shebang, okay? And you won't even write code for a year because they have to teach you how to work with all the rules. We take a different approach. I've worked in that super plan model. It's a nightmare, right? Because I have all kinds of conflicts of people working on different things. There's a lot of merge resolution challenges. So I've taken a different approach, and we do by deployable program. Okay, so a team project for us is something that is deployed and logged and controlled as a concrete entity. It's a program, okay? So there's some kind of elements around understanding how, like where we make size decisions and things like that. And again, push less than you commit. That's a big lesson for you, okay? And then push activity is what is going to move it up into the environment. Your different IDEs will have different terminologies for this. Push, sync, I don't know what Eclipse does, but they'll all kind of have their own flavor. Under the hood, as you pointed out, they're running those same commands, okay? They're running the Git commands like everybody else is doing, okay? So as you build more realistic things that are not hello worlds, that are not 265 problems, that aren't really things you'll do in college, they become very big and they have a life over a very, very long period of time. This is a visualization of one of our bigger libraries that we have. We have a principal library used by most of our programs called Gokstad. That's a boat in the Viking world. And it has lots of things that it does for us, right? Like it deals with all of our database communication. It deals with SFTP file sends. It deals with APIs. It deals with all of the things that are common that we do as developers. Why does this matter to Git? Well, when you are in an environment like this, like, well, I don't want you rewriting how I send a file, right? I want that to be done one time. So actually a large part of source control is figuring out how to break out reusable things and manage all of those at scale, okay? So another part of the Git world is dependency management and building and these problems, okay? There are other tools here like this. This is called Git Kraken. It's been around for a long, long time, and it will give you kind of a visualization of this, what they call the Git graph. Now, VS Code has this as well. I'll show you that here in a minute. But effectively, this is trying to show you complicated branching. So a good tell is if you ever interview, like, hey, show me your Git graph. And if it looks like a spider's web, you probably don't want to work there, okay? This is a little bit nicer because like we don't want something akin to, well, I had this idea and then I checked it in. And Joe was like, that's a great idea, but I think it should be this. So he branched and then he went up on his way. And then Spencer comes along and he branches. And this is actually a real situation, right? Here's a more apt use case. I'm stuck on a very complicated algorithmic problem. Joe's going to pick it up and try to work on that. he might venture on that for several months. Okay. As he moves along, he might get stuck. So he might ask you for help. You might then branch that, solve the small problem he's working on, check back into his branch. He's not yet done. Later, he'll check into me. Okay. So branches can be branched. And this pattern of like inception branching is a real thing. Okay. And so like, as you work with different organizations, they'll have different strategies for this. They can become very, very complicated. It is what makes most people think Git is the wrong answer, and they just don't understand this game, okay? The reality is, as managers and engineers and owners of these things, you want to keep it in order, right? Like, I don't want Joe branching every day. And if we start seeing that, we want to have a conversation as a team. Why are we doing that? Is that what we need to do, okay? The other thing it really shows you is kind of drift away from what is maybe your main line, right? Like as you build things out, you might be kind of drifting away and you might need to circle back and get it put back in. So this shows you some of that activity, and it'll show you things like, well, this is a line that started off way down at the bottom, and then later we came up here and we actually pushed it back to main. So, you know, it had its life for a little while. That could be something we might have explored. We might have decided to keep it. We might not have, but if we kept it, we collapsed it back into main, okay? So again, the term is like Git graph, or it's basically the visualization tool for seeing what you're doing in code, okay? And they can be very, very helpful. I will share with you, I bought this for the team as a Christmas present, and I wrongly bought gift cards that didn't let them buy it. And then they bought gifts and I bought it. And I didn't really use it for a month or like a year because, well, I'm a manager and I don't really write code anymore. And then it auto-renewed, and now I'm using it this year. So I'm trying to make it more of a point to use it. But again, I am a firm believer of open source. I live by free tools. I have my entire career. This is probably one of the only products I've ever bought. It's really impressive. One of the nice things about it for me is I can view my entire repository surface area from one program, okay? Meaning I have hundreds of repositories. If I have to augment a configuration, I might have to roll through like changes across my repositories at scale. Well, I don't want to have to open Visual Studio Code each time, and like, so these are tools that let you kind of manage things at a little bit higher level than the individual repository, okay? And what else do we got? Okay, a part that we didn't really talk about was we did git init, okay? And git init basically says, hey, I want you to begin tracking files here. That's all that does, okay? It creates a hidden folder called .git, and then it has that little internal database. If you go into that folder, you'll see some interesting files that are doing change tracking. What you also want to do is understand how that relates to your git config file. Your git config file is the settings for what's going to go on in Git, and it's going to tell the Git that you talk to, the repository system, what or who you are, and more mechanics about what's going to go on with Git. So we all went through that process of doing our Git initialization. Along with that, you got a default .git config file. This is going to be located at your home directory in Windows, c:/your username. It'll be in that location. You'll see a .git config file at that location. In Mac, it'll be under your user location, and you have it in that place as well. On the bottom right is kind of the structure of this file, and I'll talk about that in a moment. It's important to know that the Git config files work in an inheritance model, okay? So meaning, if you don't do anything, it will use the default, which is in your root user home space. However, if you want to override what that's doing, you can just put a Git config file in your repository location, and then all of the settings will be read from that file. And that's convenient. And it's convenient for people like me who have a professional job, an academic job, and then I tinker at home, and then I also have GitLab I run at home. So I kind of have a lot of places I might put code, and I don't want to crisscross those streams, okay? So what I actually have here is, you can see on the right, I actually include different config files based upon the repository that I have that code in. So these have subconfigs that have the keys and the configurations for those repository locations defined for those, okay? And again, the Git config file that you got initially is going to have the default settings for your GitHub connection, and that's perfectly lovely, okay? When you initialize, you don't tell it who you are, okay? So these parts over here, name, email, and signing key, those are, you can think of this as kind of a .json syntax. And so in the git config process, you would say git config --g, that's global. So that would augment the default config file. And then you can say like user.name and give it your name. user.email, and then you give it your email, okay? And then you'll have these values put in here. So what that does is it tells Git who you are when you check your things in. Right now, if you went and looked at it, it's not going to know who did any of that, okay? It might actually know it because of the SSH process. We don't use SSH for our commit process here, but you might want to go look at that, right? Because the value of the commits are knowing who did it and the commit messages that we got, okay? So that's the config process, and those, again, are kind of, those are done at kind of an inheritance model. So I wanted to show a couple items that we can share with you as part of this to make it more realistic. I know that we're short on time, and if people have to go eat food, go eat food. I am not that exciting. Okay, Git Kraken. One, it's got this cool little octopus dude, and it's pretty neat, and the Kraken's an amazing dude. So in here, as you navigate through, like this is that tool to show drift, you know, all of these messages on the right are going to pop up, okay? So I would have to argue with Deshaun about while our comments are useful or not, they're very useful. You want them to be good because they're on the right. So if I only put models for GIT, well, this isn't very useful, right? Well, here's a more useful one, Gokstad. So what we actually do is there's a convention around messages. The first line of a Git commit can have 52 characters, and you want to put something of use in that message. I did this to create this, okay, or version whatever. After that, every line after that can be 72 characters long. So we do this kind of bulleted thing and then just put the list of the pieces we put underneath it. And then you get this nice rendering of what's kind of going on. And again, as we kind of move through, you can see the files for what these pieces are. And again, as Ashan pointed out, this is that snapshot of the environment that we did at that moment of time that we did the commit, okay? Very useful, good stuff to see. And this is that kind of higher level view of all the repositories. And again, these are all like, these are my Cleveland State ones. I have things at home and whatnot. So a nice tool. I'm not going to tell you to go pay $100 for it, but what I would tell you is VS Code has a lot of these pieces in it too, and it is helpful, right? It helps you kind of see what's going on. Here is a representative real program. Okay, so this is one of our templates. This is that config file I opened up for you. So when we clone, you notice it's not empty. Like I'll start off and then, you know, Joe will make a new program and he gets all this stuff already with him. Well, as part of that, we have README files that are visible. And so we get this nice pre-canned little template file that he just fills in, right? And like we put the content in for what these are. On top of that, you get lots of little pieces over here that have nothing to do with the program. And again, the reason that we're doing this is we want these things pre-configured. So that way he doesn't have to go the hard work of figuring out how to do the builds and all these other parts that go along with what you're doing with Git. Again, the goal of this is we use Git to get code to a server, right? So the parts that take care of that for us are the GitLab YAML file. Okay, now, if you're using GitHub, these are going to be GitHub Actions. If you use Team Foundation Server, this is going to be a build definition in Team Foundation. But the files are basically artifacts, again, that are going to be used to tell that server how to run and build that program. Here, we're referencing them from an external location because I don't want Joe to decide how I deploy the servers. In fact, I don't want him to be allowed to define that because those are sensitive matters, right? Like the key management and the definition of how I put something on a box actually has to be controlled with security. So we deal with that process through our references and our inheritance, okay? So that's kind of the code. And while, you know, we can talk about what program code looks like, that's, you know, whatever, another topic for another day. This is that same project now inside of GitLab, okay? And so this is our instance. It's not publicly available. We manage this on site ourselves, and that's something we're contemplating whether we want to keep doing. But as you can see, the process for a file, it gets checked in and like it has history. All these things are pieces that are the stories of what we've done with this piece. And this is every time you commit and every time you push and every time we make a change, we track that, right? And we have this ability to then come back to this and say, oh, you know what? I want to get this version of the code. What changed when I did this? Here is all the code. And I can literally just go browse all the files. Like this is that instance of that. That's that snapshot when I did that process, okay? So it's very, very advantageous to kind of connect what you're doing as a dev at the command prompt, and like it has this larger story in the organization, and it's really it's interesting how much all of these things do the same things, right? Like my job has gone from just writing code to now we actually orchestrate the whole server and all of the pieces that go on. And all of that is also code and all of it has to be managed with Git, okay? So all of this really is important. And like your job as a systems admin or a programmer will all make use of these pieces because this is really what runs the whole environment. When we get to build, again, this is part of the Git process. I showed that diagram, you'll check in, and then it's gonna go through these stages and do this stuff, okay? Well, that's what this is. So we come in and we have these series of stages that get defined for what's happening. And any one of these individual stages has a whole pile of things that it does. So it wakes up, it mounts an image in Docker, it clones right here, clones in from Git, pulls that code in, runs through the process of compiling it, and nobody did anything, okay? Joe checked in his code, and it went through the process to do all of this for us. And like that automation then allows us to kind of deal with this matter that we used to have to assign people to and take a lot of time to get done. So now you have this instant feedback of, did that piece of code that I branched and checked in compile and work? And that's powerful, right? It's empowering. Before, it might have taken Joe 10 days to figure that out. Not on Joe's fault, but on mine. So over here, the other pieces are, the build process pipeline runs those tests. So the second stage of that is the test stage. So these pieces run all the .NET tests associated to it. Another one is we publish coverage reports. So he'll check in his code, he'll write tests for that. The servers will actually do analysis on all of that program and produce a website that will tell us if that is violating security standards by OWASP top 10 threats and security patterns. So there's lots of power that comes involved with like what becomes all of these things working together, okay? And again, the deployment process is just another stage. So we come through this piece, and if we wanted to run through the deploy, we just run this portion of this. I have access to do that, Joe doesn't. So what's important for you to take away from this is a very, very simple tool. It's a very old tool, actually, right? It goes back to Linux and Unix, but it is absolutely something used every moment of our day. It's a very, very important tool to understand how to make use of it. It's your friend. You want to learn what's safe, what's not safe to do, how that affects things. And like oftentimes people might get lost. Just make a copy, put it over here, reclone, and start over, right? Because nothing has to be scary about this. I think what gets overwhelming is that uncertainty about what's really taking place. Well, all that's really taking place is copying a bunch of files from a server. It's giving you a copy of that. It's then keeping track of that so you don't have to use programs like Beyond Compare to figure out what changed, okay? And then when you're done, it lets you check it in and go to bed at night and be safe. And at the end of the day, that's basically what's really happening. But there's a whole lot more involved with this that is happening behind the scenes that you can really dig into and learn about as a student as you guys approach this problem, okay? I know we're way over on time, and I could talk forever, but I really appreciate you guys letting me talk to you about this stuff, and we can do more of this and have a lovely day, okay? You're very welcome.